Okay, so in the triple representation, as the name says, it is triples. So in the quadruples you have 4, and the triples you have only 3 fields. That is, you have a field for operator, you have it for arg1, and you have it for arg2. There is no result field. Okay, the result field will be missing. Instead of result field, what is result field? It is just temporary variables, right? So instead of the result field, what we can do is we can refer to with the position number. So the record's value number or the position number itself, we can use it as the argument too. So in this table itself, I'll show you the modification. So we don't have this result field. Please write down separately. Okay, I'm just saving the time. That's all. Okay, so you have only 3 fields, right? And this is the triple representation, triples. You have op, arg1, arg2. I'll take the same example. We have already written the quadruples. You should be having the quadruples tables with you. And we'll see how to write the triples representation. So take this particular 3 address code. So you have to have 3 address code for writing triples also. Okay, so take the 3 address code. The operator is same, minus, argument is same, C. We don't have argument 2, right? So this is at position number 0. Now at position number 1, you have the operator star, then you have the argument 1 as B. Now instead of T1, since we don't have another space for the or another field for storing the result, instead of T1, what we do is we refer this T1. What is it? T1. T1 is nothing but minus C, right? What is the position number of minus C? Minus C can be referred at the address of 0th record, right? So this the parenthesis represents the address of this particular record, and the index is 0. Okay, so instead of T1, I'm referring to this particular record. Now, likewise, for this statement, it is again minus C. Then for 3, for this statement, star B, instead of T3, we'll be referring to minus C record, that is 2. So how do you say the address of 2? Address of 2, right? This is referred to as this one. Okay, we are eliminating the storing of temporaries here. Then fourth, this one, this record, T2 plus T4. T2 is nothing but you have it at 1, and T4 is at 3. So you refer to 1 and 3, right? Then for this particular assignment statement, you have the operator is equal to, now T5 and A we have. So it is going to store at A. Okay, left is first, and then the right is T5. T5 is nothing but 4. Okay, so you use the position numbers instead of temporaries to eliminate one more field from the quadruple representation to make it as triple representation. Any doubts? Use of position numbers. Instead of temporaries. Is it clear? Okay. So from the 3 address code, we have seen how to write the quadruples and the triples. Quadruples has one more extra field for result, wherein we store the result, the temporaries of each 3 address code instruction. But in triples, what we do is instead of storing the temporaries, yes.
Ma'am, from a memory, no, not from memory. Ma'am, in general, which is better, triples or quadruples?
What do you think?
Ma'am, triples is better for memory point of view, quadruple is better for processing point of view. That's why I was getting confused.
So it is a different representation. So when you're designing your compiler, depending on the memory or the processing capacity you have, all those details you'll be having, right? So based on that, you can choose which one you want to. So that's why these are all options you have. So if you think the 3 address code creation is similar to syntax tree wherein you don't do the optimization, this is more of a DAG kind where you use the address of where do you store the address of each of the record and you refer the record with that address only. Okay, so it depends on what is the space constraint you have, what is the processing speed you have at your hand for writing that particular compiler. Okay, so these are all different options available which you can use. Is it clear, Kabir?
Yes, ma'am.
So once you write these triples, there is one more. See here, some of the records, they are independent of each other. That means minus C and this minus C, one after the other, I can process. Star B of 0 can be processed once you have this 0 with you. This can be processed after 2, or it can be processed after 1, or it can be processed after 0. Okay, so there is no dependency on 1 on 2. But whereas 1 is depending on the record 0, and 0 and 2 are independent. Only the constraint is 3 is depending on 2. So what we can do is based on optimization technique or something, when you want to minimize the processing or some other constraint wherein you want to change the order of evaluation or order of processing of these statements, you can use something called as indirect triple representation. Okay, for having indirect triple representation, you need to have triples. It is nothing but the listing of pointers or two triples only, rather than listing the triples themselves. That's why we call it as indirect triples. Okay, so indirect triples, I'm just erasing this 3 address code. This is no longer required. I have the triple representation. So in indirect triples, I'm just listing the pointers for the triples. Okay, so it will start from somewhere in the memory, like if I say it is starting from 35, so I go on listing only the pointers to this triple records, each of the records. Okay, so 0, at 36 I have 1, at 37 I have 2. This is a straightaway listing of similar to the triples record. I will show you the other listing as well, wherein we can change the order of processing of these triple records. So 39 is 4 and 40 is 5. Okay, this is one listing. Then the other listing could be, I can start with 0. I can have 2. Then I can have 1. Then I can have 3. Since 4 is depending on both 1 and 3, so it should appear after 3 only. So 4. Then 5 is depending on 4, so it should appear after 4. This is another representation of or another listing of the triple representation. So this is called as indirect triples. Okay, these consist of a listing of pointers to triples rather than a listing of triples themselves. Okay, so this is indirect triples. So we have seen 3 address code from there: quadruples, triples, and indirect triples. For indirect triples, we need to have triples representation. Now, one more form which is left is static single assignment form. Okay, if this is clear, I can go to that.
So,
Any
ma'am,
questions?
the first one is direct writing down the address blocks of the triples, and the next one is depending on the order in which they appear. So the independent ones occupy the first two cells and like first row, first sequence, and then after that sort of.
Yes, it is a different listing I have shown, which you can have. So it's the pointer listing, right? So to differentiate from the straightaway listing, I have just shown how the other listing could be.
Yes, ma'am.
Okay. Now, coming to static single assessment form, in 3 address code, you see that compilers will generate as many temporary variables as it requires to satisfy the condition of having two sources and one operator at each instruction. Okay, so the same temporaries can be reused later. The same T1 can be reused later, and the once its task is over, again it will be reused later in the 3 address code instruction. But in static single assignment form, as the name itself says, static single assignment form, we call it as SSAS. Okay, so this is a recent form which is formed. So here what happens is you are not reusing the same temporary variables. In two ways, this is different. The SSA is different from 3 address code in two ways. The first one is all assignment and SSA are two variables with distinct names. Okay, all assignments, I just write down all assignments so that you remember it. Assignments in SSA are two variables with distinct names. Who is trying to enter? No. Okay, that means if I have a 3 address code, something like this, A plus B, then P, Q and all, they are temporaries. It is not compulsory that it should start with T only. Okay, so P minus C, then I can use, because the P's value is already been used in this particular statement, which was there before here. So the same P can be reused in the 3 address code. Okay. Now, this can happen in 3 address code. Okay, so when you take SSAs, this is not allowed. So it is always to a variable itself, not a temporary. So I need to have a different variable every time to store the result. So I have to say Q1 is equal to P1 minus C, and then I cannot use P1. It has to be P2. Okay, P2 Q1 star D. So every resultant variable where you store the results is to the variable. Here it is the temporary. This is the tag, and this is the SSA. That is the main difference between 3 address code and the tag, the first one. The second one is, if you see, I'll give you an example. If I have something like this, if flag, okay, so X is equal to -1, else X is equal to 1. This is a statement. After this statement, if else statement, I have Y is equal to X into A. So now Y is depending on the X value, which has been computed before. Okay. Now in 3 address code, how will you write this? Now I have to use labels and stuff like that, but the value X is getting used. Okay, the value X only is getting used, and where the Y is depending on X. Now, I don't know that what is the value of flag when I'm compiling. The flag will get the value only at the runtime. So based on the flag's value, X value will be assigned, either -1 or +1. So in SSA, there is a unique function called as phi function. Okay, so in SSAs, what it does is, if I take it directly, so if flag, I say x1 is equal to -1, else x2 is equal to 1. Okay, so x3, I can take it as a phi function, which is nothing but x1 and x2. So at the runtime, what it does is, whatever the path is taken here in the conditional flow, whether it is true or false, which value is getting assigned, that will be taken for x3 value. If flag is turning out to be a true value, then x1 will become -1, x2 will not get any value. So this phi function will return the value of x1 to x3. Then I can use, again, I can split this up. I'm just writing for the sake of understanding how the phi function works. X3 into A. So this becomes easy, as in I don't have to, write a backpatching code for this. If you use stack, we will see in the control flow coming up next. We have to use backpatching because we have to generate 3 address code for this particular statement and also for this particular statement. Here it is a simple one-line statement, but every time that is not true. So based on the runtime execution, I have to do backpatching, a technique to, properly find out or properly jump to the 3 address code where I have to, based on the flag's value. Okay, that is avoided in SSA representation. You can have this phi function and then use the phi function to return the values. Okay, based on whether it is true or false. This is the second thing which is different from the tag. Rest everything is similar to tag. How you write the two sources, one operator, everything else is similar to tag. Only the difference is it is to a unique variable and the use of phi function. These two things are different in SSAs. Okay, so this completes the whole representation of intermediate codes. It can be syntax tree or DAG in the tree representation. More general is 3 address code, and from the data structure point of view, it is quadruples, triples, indirect triples, and SSAs.